Hey y'all, we're going to look at one of your other learning targets for Unit 5. This is I can identify a synthesis reaction, decomp reaction, single replacement, double replacement, or a combustion reaction. And since we have this little bit of space over here, I am going to write myself a little bit of a cheat sheet on this side. So for synthesis, this is when you're going to take reactant A and reactant B. You're going to end up with a product that is a combination of A and B together. Okay? The second one that we're going to look at is decomposition. And that's the exact opposite of synthesis. Decomposition always means to break something down. So that means we're going to start with something, with a substance of some type that is already together. And then after the reaction takes place, we're going to be left with not one, but two entirely separate substances. For a single replacement, and I usually just write SR for single replacement, the easiest way to think about this is that it's got to be an element plus a compound. And then they get jumbled around during the reaction, and you end up with an element and a compound. Okay, and I'll give you an example of that in just a second. The next one that's on the list is a double replacement. And double replacement means exactly what it says. It means that you're replacing double the amount or two things. Single always means that there's one thing that's happening, and double means that there's two. So in this case, instead of it being an element in a compound, because an element is only a single object, right? In this case, it's a compound and a compound. And then after your reaction, you end up with a different version of the same thing. And then finally, my favorite is, my favorite is combustion. And this is really a fancy way to say that something is burning. Okay, and I like them a lot because they're super easy to identify, because every single time that something combusts or something burns, after the reaction, whatever's over here is fine. After the reaction, you end up with a combination of H2O and CO2. So for example, let's start here at combustion and work our way kind of backwards up the list. Let's go over here to the left-hand side and see if we can find any of these equations that end up with H2O or CO2. So for example, that one is CaCl2, so that's not going to work. This one is BaO and CO2. It does have CO2, but it does not have H2O. It has to have both things, so that's not combustion. This one, the third one down, has CO2 and H2O. So what does that tell us? It's combustion. Okay, we'll go to the next one that has the products after your yield sign, after the reaction. You have NaCl and oxygen, so that's not going to work. Here's your arrow for this one, and we have CaCO3 and some other stuff, and that's neither of those are water and carbon dioxide. This one is not. Nope. This one down here, the one that has an H beside it, and it looks like some of my numbering got messed up. Sorry. You have CO2 and H2O, and so in that case, you have both. You qualify for. And what that means is that this reaction that's taking place right here, indicated by the arrow, is really burning. We call that burning. If you go a little bit further down, KNO3, no. KOH, no. Cr2O3, no. H2O, CO2, yes, could be. So the last one down here could also be or is combustion. Okay, so if you look at your list and you check everything off, then if we started with combustion, we found all of the formulas that are representative of combustion. So now I like to go all the way back up to the top and let's start and work our way down. Let's work with synthesis, then decomposition, then single replacement, double replacement. Okay, so synthesis is when you start with A plus B and you end up with A and B that are added together or joined together at that point. And when they're joined like this, they are bonded to one another, so they can't be separated. So for A, right here, I have Ca plus HCl yields CaCl2 and H2. So that does not qualify because these guys over here, your products, have a plus sign. It's not A and B together, it's A plus B again, so that doesn't work. This one starts out with 1 and ends up with 2. So you start out with one object and you end up with 2. You can tell there's 2 because they're separated by a plus sign. This one is combustion. The next one is 2NaClO3. So that's one thing here. After the reaction, you end up with 2 things. So that's not synthesis. I'm just going to give it a guess and say that this big, huge one here is also not synthesis. So we'll skip down to that teeny tiny little F right there. And you have 8 coppers, Cus, plus 8 sulfurs yields 8 Cus's. And so you have A plus B after the reaction yields AB. So this one is synthesis. The next one has P4 plus 5O2 yields 2P2O5. So you have A plus B yields AB. So this one qualifies as synthesis. And this one is combustion. The silver AgNO3 has 1, 2, 3, 4, so that doesn't qualify. This one has got 2K and 2 water, so that one doesn't qualify. And the last one that we have available is 4Cr. That one looks like it might. So we have 4Cr plus 3O2 yields 2Cr2O3. And so you have A plus B yields AB. So this is also synthesis. Now I'm going to switch over and I'm done with synthesis. I'm going to look for decomposition. So now I'm looking for one thing that has been broken down into 2 things. And I do remember earlier when I was looking at this one. So here's barium, BaCO3. After the reaction, you have 2 different compounds. So 1 compound before, 2 compounds after. That means that you started with 1 and broke down into 2. That is decomposition. Okay, down here I had already put boxes around this. So this means that you're starting with 1 compound. This would be our AB compound. And after you broke it up into A and B. So this is also decomposition. This one has a compound plus a compound. After the reaction, you have another compound. Sorry, got interrupted there. So for this one, we have a compound plus a compound yields a compound and another compound. So how many compounds do you have there? Compound, 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 compound. So no elements. So this one is going to be double replacement. Let's go back up and look at this one. You have an element here plus HCl is a compound, yields a compound and an element by itself. So this one would be element plus compound turned into element and compound. So that's going to be single replacement. Down here, you have silver nitrate. Compound, 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 compound. So you've got compound, 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 compound. That's going to be double reaction. You come down here to this one, you have an element. This is why it's so important to know the difference between elements and compounds. You have to be familiar with that. Remember, you can't find a compound on the periodic table. You can only find elements on the periodic table. And that's going to be a single reaction. All right, hopefully that was really helpful to you guys. If you have questions, let me know.